Good morning all. Now I would like to discuss about types of sources. Okay, see here majorly there are two types of sources, dependent sources and independent sources. See here dependent sources are depends on another variable, that is nothing but dependent source. See here this is the representation of dependent voltage source and here it is the representation of dependent current source. Okay, to understand this concept let us draw the circuit diagram. Okay, here V1 is the supply voltage. Because of the supply voltage, I1 is current flowing through this circuit. See here, this is the dependent voltage source. This dependent voltage source depends upon another variable. Okay, that is nothing but dependent source. Dependent sources depends upon another variable. See here, this voltage source depends upon this current. That is nothing but dependent source. Okay, next coming to independent sources. Independent sources are does not depends on another variable. Okay, those dependent sources are again classified into two types. Okay, first one is voltage source, second one is current source. Okay, first we will discuss about voltage source. Okay, voltage source also is again classified into two types. There are first one is practical voltage source, second one is ideal voltage source. First we will discuss about practical voltage source. Every practical voltage source is having a series resistance. Okay, this is the practical voltage source. Every practical voltage source is having a series internal resistance, that is series resistance. Okay, this value will be very less. Okay, because of the presence of this resistance there is some voltage drop across this resistance, right? Then Vs and Vl both are not equal. Okay, if we apply KVL here minus plus minus Vs. Okay, for plus minus plus, current flowing through this series resistance will be I into Rs, plus minus for plus, voltage across load will be VL is equals to 0. Then Vs is equals to VL plus I into Rs. From this equation, load voltage VL is equals to, see here, load voltage VL is equals to Vs minus I into Rs. Okay, if I draw the graph between current versus load voltage, right? If we increase the current, okay, this drop will be increases. When this drop is increases, VL value is reduces, right? VL is equals to Vs minus I into Rs, right? For example, Vs assume 20 volts minus I value will be 1 into 1. If I value increases, 20 minus 1, 2 into 1, 20 minus 3 into 1. That means voltage drop increases, means if we increase this drop, this resultant value will be reduced, right? That is shown here. Okay, for an practical voltage source. Okay, hence in case of practical voltage source doesn't have constant load voltage. Okay, here load voltage is variable, that is depends upon the load current. Okay, that is about practical voltage source. Next coming to ideal voltage source. Every ideal voltage source is having zero resistance. Okay, when this resistance is 0, the voltage drop across this resistance is also 0. I into R, right? Voltage drop across this source resistance, then this value is 0, means Vs is equals to VL. Then voltage across the load will be constant, right here. If I draw the graph between current versus load voltage, and here source voltage and load voltage both are equal, hence Vs is equals to VL, that is constant. Okay, that is about voltage source. Okay, next coming to current source. Again this current source also again classified into practical current source and ideal current source. Okay, practical current source is nothing but every current source is having a parallel resistance. See here practical current source will have a parallel resistance. That value will be very high, not is equals to infinite. Okay, and here load will be connected across this parallel resistance, right? Then voltage across the load will be VL, right? Then total current Is is equals to IRS. IRS indicates current flowing through the source resistance plus IL. Okay, then apply KCL here. Is is equals to IRS plus IL, right? From this equation, IL is equals to Is minus IRS. Okay, if I draw the graph between load voltage versus load current is equals to Is minus I into Rs, right? IRS is nothing but VL by RS, right? That means this value, if this value is increases, when we increase VL value, this value is also increases, right? See here, IL is equals to Is minus VL by RL. Here when we increase, if we increase this VL value, this value increases. When this value increases, this drop will be increases. That means load current value will be reduces. You can observe here, that is IL is equals to Is minus IRS. Hence here practical current source doesn't have constant load current. That is doesn't have constant load current. Okay, that is about practical current source. Next, coming to ideal current source. Every ideal current source will have infinite parallel resistance. See here infinite parallel resistance is nothing but Rs. It acts as a open circuit, that is Rs is equals to infinite, right? Then no current is flowing through this branch, right? Hence Is is equals to IL. Okay, if I draw the graph between load voltage versus source current, okay, here Is is equals to IL, right? Hence ideal current source has a constant load current. Okay, that is about voltage sources and current. Thank you all.